Let's go to Liquor 2767. Partition string into minimal beautiful substrings. So we're going to give a binary string S, and we want to partition this substring into minimal number of beautiful substrings. So beautiful substring is that it doesn't contain leading zero, and its binary representation is a number that is a power of 5. And we'll see this string has length smaller equal to 15, right? So that means we can check, for example, um, binary of 5 power 6 to binary format. So it has length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So 5 to the power 6 and the power 7 will be out of range for 15, right? So let's look at power 7 to binary. It has a very big number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, right? So we know actually for this kind of binary, there are only from 5 power 0 to 5 power 6, right? Only 7 combinations. So the first thing is that we'll see if this kind of string is start with, right? Start with leading 0. Of course, we need to return 0, right? Return -1. So it is impossible. Always you just write chat 0, right? Chat at 0 equals 0. Just return -1. And what we think about is that we just have this kind of binary string generated first. And then there are multiple ways because this data is very small, right? Only 15. We can do DFS or we can do DP, right? DFS is just we for those kind of number, which is let's see, five to power number, they will always end with 1, right? So we try to DFS those kind of partitions, and then find the shortest. And for we can also do DP way. So for int DP, right? Equals new int 15. That means at this index, what is the smallest partition we have so far, right? So, for example, at index I, we can there is for this small number, we can of course have this I and also have a j is smaller than I. Do two follow trying to see whether they belong to this um, 7 strings, right? You can use a set to contains or not. And then have this kind of j minus 1 as dpj minus 1 plus 1, right? To have a minimal smallest to set as di, right? But to do this one, even this time, this data is very small. It is just O(n) squared, right? Time complexity. So the the best, I think to get a time complexity better is that instead of we iterate G from 0 to I minus 1, right, we can just iterate those kind of seven numbers. And we don't need to use a set, right? Just use a list. Seven strings, right? Trying to see if this part is this any of this string. And then we find this J and use this J minus 1, dp J minus 1 plus 1, right? And one of the corner case we want to care about is the whole thing is binary string of this seven. Then dp J minus 1, this J minus 1 it itself, it is a negative number, right? So we should have corner case if this is a minus 1, we just set this one as 0. So let's write code for this. We are going to use a list of string. List equals new array list. And we're going to have interface equals 1 for int I equals 0, I smaller than 7, I plus plus. So we're going to have base should multiple equal to 5, right? And our list just add a integer to binary string base. Okay. And let's have n equals s dot length. So let's have a dp, right? Int dp equals new int n, and let's have arrays. Let's set private static int I f equals integer dot max value ratio 2 array to dp f. There is an initial value dp0 to be 1. The reason is that if we start with 0, right, it will return minus 1. So all of these string, or if we go to this step, they are always start with 1. So at the position 0, we know there is a binary array that 5 to the power 0, right? So it have one choices. So it is set as 1. Then what we do is we go through the string for int I equals 1, I smaller than n, I plus plus. And we know for those kind of power 5, these seven strings, they cannot end with 0, right? So if s dot char at I equals this 0, we just continue it. Don't need to do any calculations. And for string str in this kind of list, so we are going to have int l equals str dot length, and we'll say if this kind of l greater than I plus 1, right? We don't have enough this string, we should also skip, right? Just continue. And let's have a string, C string equals S dot substring from I minus L plus 1 to I plus 1, right? So let's say if C string equals this str, right? So we are going to have a dpi equals s dot min dpi And this should be dpi minus L, right? Plus 1. But the thing that this my I minus L may be negative 1, right? So if this happens to be the whole string, this will be negative 1. So we should what we should do. So anyway, it will add something, right? So we can write something like this: 1 plus. So if I minus L is greater or equal to 0, then it is dp I minus L, right? Otherwise, it is 0. So in the end, we just return dp I minus 1 if this is smaller than I in F, right? So it will be dp I minus 1. Otherwise, we just return minus 1, saying it's not possible to partition. Okay. So doing like this, it will be 7 multiplied by n time complexity and with the ON space complexity. And we can also write a Python code for this. So we're going to have mm, if S0 equals start with 0, right? That means it's return minus 1. And we are going to have a dp. We can we let's first generate the binary list, B list. Uh, so we're going to have base equals 1 um, for this one in range 7, and we have base should multiple equal to 5. And we're going to have B list. We are going to append bin base. This is a binary format. Then we are going to have n equals length of s, and dp equals float inf multiplied by n, and we'll have dp0 equals 1, right? It will always be b1. Then what we do is that for I in range from 1 to n, and for first, if Si equals 0, we should continue, right? Because it's impossible for any 5-power number which end with 0 continue. And what we do is that for B string in B list, so L equals the length of B string, right? So let's say if L greater than I plus 1, we also for this kind of binary string, we just continue. And we'll write if S I minus L plus 1 to I plus 1 equals this B string, then we'll have dpi equals min dpi, and 1 plus. So here dpi minus L, if I greater equal to L, else 0, right? So in the end, just return BP minus 1 if BP minus 1 unequal to INF float INF else that is minus 1.